Hi class, I just want to take a few minutes to talk functions here. I'm hoping that the majority of what I go through on this is going to be review. Most of this is standards that you've seen before. So if you say, I definitely know how to do that, you might sort of need to determine what you want and or need to write down in notes. I just want to make sure we're sort of on the same page when we come back to school next week. And then I'm not talking about words you completely forget or you've been out of school for so long you forgot. So this is sort of your brief reminder. So first of all, we are talking about functions, but I want you to understand that functions falls in a bigger category. And the big category is relations, okay? And there's a bunch of relations that exist. And some of those relations are going to be the specific type we call functions, okay? Just like the letter C is part of the alphabet, right? But there is one specific type of letter that we name C. And relations we can represent in a bunch of different ways. So we can represent relations as ordered pairs, okay, where ordered pairs are always made up of an X, comma, Y. Okay, so maybe I have a relation that's talking about my favorite number versus, I don't know, a neighbor's favorite number. I mean, it can be totally random. It doesn't have to be anything that matters. Okay, I'm comparing a bunch of people's favorite number. My favorite number's student's favorite number and Mr. O'Neill's student's favorite numbers, whatever. Okay, so we come up with a relation that's -3, 7, 2, 5, -6, 8, and 1, -4. Okay, relations can then be represented in various ways. So I can take those representations and not just have it in ordered pairs, but I could also list it as a table. And a lot of my students have been calling these T-charts. Okay, technically it's a table, but you might think about it as a T-chart. Okay, where in a table, we have our X values on the left and our Y values on the right. So I could take this -3, 7, and I could put it in my table as -3, 7, 2, 5, -6, 8, and 1, -4. Right? I should also be able to look at this table and realize that this represents the ordered pair -3, 7, and I could go back up. Okay, we can represent these as points on a coordinate plane. So another name for the coordinate plane is a Cartesian plane. Okay, but this is where we're plotting on the X and Y axis. Okay, that maybe we want to plot some points. Hopefully we know that when we're plotting an ordered pair, we do the X on our horizontal and the Y on our vertical. So I could plot the point -3, 7. I could plot the point 2. And again, I'm just making a totally generic coordinate plane here. I will be giving you some copies of coordinate planes to have at home for different assignments, so you have those. We could do -6, 8. Oh dear, that wasn't quite lined up. 1, -4. Whatever, okay? We can plot points. If you say you don't know how to plot points, you should definitely be reaching out to me and making sure that we clear that up. The last way that we can represent relations is with a mapping. Okay, this should also be reviewed, but this is the one we do the least of. Okay, and a mapping is where we sort of have two ovals. That's a terrible oval, but pretend. And we're going to put our X values on the left and our Y values on the right. But the thing to keep in mind is that the numbers have to be in numerical order. And there can be no repeats. Okay, which means when you're listing your X values, so I'm going to look at either, right, I could look up here to find my X values. I could look here to find my X values. I could even name these points, right, find my X values from the points. I'm going to list all of those X values over here in numerical order. So -6 is the smallest, -3, 2, and 1. Okay, then my y value is -4, 5, 7, and 8. Now the key here is that if I had another 7, so let's just pretend for a second that in this table I also had the ordered pair 1, 5, I would not write down 1 twice, nor would I write down 5 twice. I'm only writing it once. Okay, and then once I have those numbers, I want to draw a line between the things that connect in an ordered pair, right? So -3, 7, so I'm going to have a line from -3 to 7. 2 goes to 5, -6 goes to 8, 1 goes to -4. Okay, these are all different ways that we can represent relations. Now, these representations are the only way that we can talk about actually seeing how the x and y go together. We should be able to work in between all of them, which means if I'm given an ordered pair, I should be able to make a mapping, plot the points, turn it into a table, or any sort of order. Now, there's one other piece that we can talk about, but it does not give us that sort of fluid we can work in between all the options. This is just something we can talk about. Okay, we can talk about a domain, a range, okay, and an inverse is one other small thing we're going to add. The domain and the range go together. Well, kind of. We typically talk about the domain and the range together. The domain is going to be our x values, and the range is going to be our y values. Now, when we list a domain and a range, we have to be very specific with how we are going to list it. We can't just sort of pull x values and write them down. So the first thing that we have to have is we have to have it in braces. So my students often tell me I'm really bad at drawing those braces. Just make a squiggle. Okay, it needs to be a brace. We don't want it to be a parenthesis because that represents an ordered pair. Okay, this is how we represent that things belong together in a set. Okay, then we also write them in numerical order with no repeats. So we're doing that same thing of numerical order and no repeats. Okay, so since I already took care of that in my mapping, I'm just going to copy it from there. -6, -3, 2, and 1. But again, if you were pulling from a table and a number showed up twice, right, you wouldn't write it twice, and you'd have to rearrange to get them in numerical order. Now, your range, you're going to do the same thing for. In braces, no repeats, in numerical order, but now we're just talking about our y values. So our y values, again, I already took care of that in my mapping, are -4, 5, 7, and 8. Now, as you can tell, this is it for the domain and range. This doesn't tell me what x pairs up with what y. So there's no way I can go from having a domain and range to anything else that is up here. Okay, I can get the domain and range from any of these, but if I'm only given the domain and range, I can't go backwards to anything else. The last thing that we're going to talk about in this list is an inverse. Okay, an inverse kind of sounds exactly like what it is, right? It's to undo. It's kind of the flip-flop of it. So if -3 takes us to 7, 7 would then take us to -3. So we're just going to take the ordered pair and write it in reverse order. So instead of -3, 7, I'm going to write down 7, -3. Okay, again, I'm going to use those braces to show that these are grouped together. Those are a little bit less important. 2, 5 is going to become 5, 2. -6, 8 is going to become 8, -6. And 1, -4 will become -4, 1. Okay, all of those representations work for any relation no matter what. Okay, but some of those relations are going to be a special type of relation that we call a function. And how we determine if one of them is a function is we will see no repeats in the x value. Now, if we look it up in the textbook, we'll see a really fancy definition that says every number in the domain is paired with exactly one number of the range. But that's just a fancy way of saying that our x value can't be repeated and have two different numbers that it partners up with. Okay, so if we want to determine if something is a function, maybe we'll be given a relation. Just going to make one up here really quick. Okay, maybe we'll be given this relation with ordered pairs, and we want to determine, is this relation a function, right? They're all relations. It's represented as an ordered pair. It has to be a relation. But is it the special type that we are going to call a function? Okay, and the way that we will determine that is by checking to see if the x value repeats. So we're just looking at the x, no y. Okay, so we're just looking at the x. Okay, we'll see if any of those numbers repeat. Do any of the x values repeat? No. Now this question feels a little backwards. Since the x values don't repeat, yes, it is a function. Right? There are no repeats. No repeats means it is a function. Maybe if we are given a table. So again, I'm just going to make one here really fast, make up some random numbers. Okay, we know this is a relation and we want to decide, is it a relation that qualifies as a function? Now, you might be tempted to go, well, this all has 2's. But remember, the y value has nothing to do with it. The only place that we want to look is over here in the x column. So those are the only values that matter. Okay, so if we look, 3, 5, 1, 3. Oh, right here, we see that 3 is used twice. So the x value does repeat. So no, this is not a function, right? It's just a relation, but not the special type of relation we call a function. If we were given a mapping and we wanted to determine, again, I'm just going to make something really quick. Okay, so if we want to decide if this is a relation, the key here to understand is that we gave directions that there couldn't be a repeat. We can't write that repeat down. Okay, so instead what we need to do is see how many lines there are. 1 has 1 line, so it's used once. 3 has 1 line, so it's used once. 5 has 1 line, so it's used once. So none of those are repeated. If we saw something that had a second line coming from it, this 3 would now be used twice, and then we could say, no, it's not a function. So if everything has 1 line, it is a function. If it has 2 lines, it's not a function. And again, it's only the x's that matter. Doesn't matter how many lines are happening over here. Now the trickier piece is determining on the coordinate plane because we don't see the numbers. Okay, so let's say this time, instead of it just being random points, okay, we have a graph of a shape. To determine if this is a function, we want to see if an x value repeats, and the way that we do that is with a vertical line test. Okay, so what we want to do is use another sheet of paper, maybe a Post-it note, the side of your pencil, a ruler. We want to see if we can find a place where when we draw a vertical line, okay, so if I draw this vertical line on the side of my Post-it, how many times does it touch my graph? Okay, it touches twice. If I can find any number of vertical lines, 1, 3 of them, 1,000,000 of them, an infinite amount of them, right? If I can find any vertical line that touches twice, we would say, no, this is not a function. Now again, it doesn't always have to be a shape. It could just be points. So if we again do vertical lines, nope, that only touches pink once, only touches pink once, only touches pink once, only touches pink once, only touches pink once. So since those all only touch pink once, we would say, yes, this is a function. But again, all it would take is an extra point to be right here, right? And then I could draw a line and it would touch it twice and we would say, no, it's not a function. That's it for our video today. We will discuss more with this next week. Have a great long weekend.